Today we're going to do a lab where we are going to launch a projectile off the edge of a desk and measure and predict where it's going to land. So this is the setup. You have a ramp that's going to drop a marble along the incline, and then it's going to move through these two things. These are called photo gates, and then it'll fly off the edge of the table. Okay, if we look at that from the end, the marble's going to go down the ramp through these two photo gates, so you got to line everything all up here so that the marbles are going to go straight through the photo gates. This is what it looks like from the top. Okay, and you can see the marble comes off the ramp, moves through these two photo gates. What the photo gates are going to do is there's a little infrared beam that jumps between them, and when the marble goes through the first one, it's going to actually start timing. When the marble goes through the second one, it's going to stop timing. So we're going to get a change in time. Okay, in order to get a velocity from that, we also need to know how far it traveled. So we're also going to need to know the distance between these two photo gates. Okay, setting this up is a pretty straightforward process. The biggest thing is to make sure that this first photo gate is actually in digital 1 and the second photo gate is in digital 2. There's one more measurement that we need to make in order to actually collect data and get this experiment started, and we need to measure the distance between these two photo gates. And this is critical because this is the distance that the LabQuest is going to use in order to calculate the velocity. The easiest way to get that measurement is to use a ruler and break the beam and record when the beam breaks with a mark on the desk. Alright, so if you slide the ruler in a little bit at a time, you'll notice this light lights up. Okay, that light is telling you the beam is being blocked. So right when that light lights up, I'm going to put a mark at 18 centimeters. Okay? And then I'm going to take the ruler and I'm going to slide it a little bit further through until the next light lights up. Okay? So there it is. The first one's broken, so timing would start right now. Slide the ruler through a little bit, and then that second light lights up. Okay? As soon as we get to the position there, I'm going to mark 18 centimeters again. Okay? So on the desk, mark 18. It doesn't have to be 18. It can be whatever number you decide, but it needs to be consistent for both of them. Okay? This way, I can measure the distance between these two marks, and that'll tell me the distance between the two photo gates. Now we're measuring in centimeters, but we're going to want to use millimeters, or sorry, regular meters, when we actually put this into the LabQuest. Okay? So this is 2.8 centimeters, but that's the same as 0.028 meters. To set the sensors up, the photo gates up, we're going to go to the sensor setup menu and we're going to choose sensor setup. And that's going to pop up with a list of a bunch of things we can choose. Under digital 1 we choose photo gate and push OK, and then we'll repeat the process, and under digital 2 we choose photo gate eventually, and again we'll push OK. Alright, now there is one more change to make, but we've got our two photo gates set up, and if we push OK, it takes us back to the meter screen, and we can see that it's seen both photo gates and they're both unblocked because there's nothing moving through them right now. Okay, so if we go over to the right side of the screen and we choose mode, okay, we're going to change it. Photo gate timing's right, but it's not motion photo gate, it's pulse photo gate. So we're going to leave that alone, but we're going to come down here to photo gate mode and we're going to choose under this drop down menu pulse. Okay, and that's going to actually time how long it takes to go from one gate to the other, which means we need to know the distance between the gates. Okay? This needs to be a very precise, very accurate measurement because all your velocities are calculated using this distance and the time it takes for the ball to travel the distance between the two gates. Okay? Alright? And that's in meters, so we're going to have to make sure that we're going to measure in centimeters, but our units are going to end up in meters, so we'll have to do that conversion. Okay, now we're ready to collect data. We've got pulse timing set up, so we're going to click here to the graph screen, and then it's going to show up, and we push collect, and it's waiting for us to collect data. So if we take the marble and roll the marble through the photo gates, it's going to pop up with a data point. Okay, and that data point is going to be the velocity of the marble. So right up here, okay, it says, look, I've got a velocity of 3.2 meters per second. It's still collecting data, so if I were to roll the marble through the photo gate again, it's going to collect that next data point. Okay, and so when we do that, we get another data point. Here it is. It also looks like 3.2 meters per second. That's good. We're rolling it down the ramp. We want it to be the same. You guys are going to collect a total of 10 data points. There's one more. You just keep rolling the marble through. Now, once you've collected 10, what you're going to want to do is stop data collection, and then it'll zoom in on the graph. But it looks like a lot of random motion, but it's not. I mean, if you look, your lower limit's 2.96, your upper limit's 3.03. So this is a fairly concise graph. And then we're going to go Analyze Statistics, and we can choose to look at the minimum velocity, the maximum velocity, and the mean velocity over here. And those are the numbers that you're going to need in order to work out the distance the ball is going to travel before it hits the ground.